Okay, so welcome everyone to this week's compiler architecture meeting. So today we have one topic to discuss. So Samer from the University of Alberta will be talking about a proposal to change some of the way that we're doing extensible classes. So we've called it revirtualization. So I'll let Samer take it away. If you need to take the screen over and like that, just let me know, and or just take it.
Thank you, Jared. Yeah. So our proposal today is to change the polymorphism from static to hybrid, and it is based on trying to understand if a new developer comes to want to contribute to OMR, how would they do that? So as a new developer, if they want to extend OMR for their language, they would not have a good understanding of which functions should be overridden. So all the functions are overridden using static polymorphism, and they use self inside them, but the developer wouldn't know which ones they should keep as intact, because changing them would actually change the behavior of OMR totally, and which ones should be actually changed. That's one issue. We found that in other words, there's no documentation for which functions are the part of the API or the functions that they should be changed. And the second issue that we found is that the function, the use of self, is a bit confusing. I definitely understand the self function is used to solve an inevitable problem in static polymorphism. However, for new developers, they wouldn't it takes time to understand exactly how they should use it and why they should use it. So that's why we have our proposal to change from static polymorphism that makes us have to use self into a more hybrid polymorphism. So the proposal is actually made of two parts. The first part is to mark all functions that are expected to be overridden, or in other words, API functions, with an annotation. The name of the annotation, we're still not sure of it. Matthew was suggesting OMR Extensible, Mark was suggesting OMR API. However, it's something similar to OMR Extensible that's used next to the class declaration. We would have another annotation next to the function declaration, and for now, I think OMR, I'm going to call it OMR API. So then the new developers, when they want to start extending OMR, new language developers or client developers who would want to start extending OMR, they would just search for OMR API, and they can find all the functions that they should or are expected to extend. Another part of the proposal is to virtualize all the API functions, to change them from static polymorphism to dynamic polymorphism. And this is mainly to remove the use of self, so that all developers who are starting new or language developers don't have to understand the idea of having self and use it. This also gives us, virtualizing functions also gives us the advantage of having pure virtual functions, which basically force developers to override functions because they are made in a way to be overridden. We realized that there might be a performance issue when we virtualize some of the functions. However, the hypothesis we have so far is that the functions that are expected to be extended by developers, the API functions, are not used enough to actually degrade the performance. However, we can always keep, after virtualizing any class hierarchy, we can run benchmarks again and make sure that this is actually the case. So this is basically our proposal. Any questions or comments about it?
Okay, well, I guess I'll start with one. If we are talking about looking at measuring performance with virtualized dispatch, the evaluation will need to include a broad set of compilers when doing that. It's not just enough to say that, oh yeah, it works with GCC or whatever, because different platforms have different build compilers, and those compilers can have radically different capabilities when it comes to de-virtualization or optimizing the virtual method dispatch. So that would be a key concern of mine, is that the evaluation is sufficiently broad to make sure we don't miss something in that regard.
So I'll say something here. So for evaluation of the performance impact, I guess, what we discussed earlier was that we would make the changes, and then Samer will make the changes, and then pass some standard tests that he will run with GitHub and whatever CI. And then we'll take his change set and do all the compiles that we do internally, give the build, and then give it to the performance team, like Beverly's team, and then do all the benchmarks that we normally do. And I don't think there'll be a huge performance impact, but we have to evaluate once we get the numbers back. Maybe some threshold.
So if you're thinking about compilers as well, I mean, I don't think we're just picking Linux as an example. We're not going to be stuck on GCC 4.4.7 or whatever I think we are right now forever.
Right.
So if you were to do an experiment with that compiler and you get a certain level of performance that isn't necessarily great, you might actually get a lot better performance if you were to run with something like GCC 7.3.
Mm-hmm.
So I think you want to keep the future in mind as well if you're going to be doing any kind of performance investigation, just so that there's the possibility, because if this is a solution that we're going to go with longer term, it's potentially going to be with us for a while. So we want to make sure we at least keep up with what the latest compilers are able to do with it.
Yeah.
You're suggesting that maybe new compilers would take more time to compile it?
I'm thinking that newer compilers will do a better job of it.
Okay, yeah, I see.
And so if you get poor results with, let's say, current levels of compilers, you may get better results with...
But I guess given the dependency on, the OpenJ9's dependency on OMR, what is the acceptable threshold for performance degradation?
I don't know. I don't know if I can give an answer on that, but I think that let's see the data first. And kind of.
I think there would be I think the tolerance for degradation is proportional to the benefit that's perceived to be that we're perceiving to be getting from it. So if there's engineering, implementation benefits, and runtime costs, those things have to be traded off, and they have been traded off at various points. But I think that
it's difficult to, as you say, to make that sort of determination without the hopefully cleaner code on one side and whatever regressions and n different benchmarks on the other side.
Mm-hmm.
Right.
I don't think that I don't think we can draw a line in the sand. Because you may end up with most benchmarks having no problem and one of them having a massive problem, or you may end up with a small parasitic that's sort of all over the place and saying, oh, well, we'll accept this or accept that. I think it has to be evaluated in the context of the benefits that the proposal has versus the drawbacks that it has from a performance perspective. I don't want to rule anything in or out. I don't want to be unfair and dismiss it on some arbitrary threshold because, oh, it regressed one thing, but we see all these other benefits. That wouldn't be fair. It's also not fair to say, well, it met all these thresholds, but it's actually kind of bad all over the place. We're still going to take it.
Okay. So we will definitely go collect the data, and then we can discuss at that point once we have concrete data.
So my question, one question I have is, how did you identify what the extension points are? Did you just look at what is currently being overridden and then therefore say that is an extension point?
For now, we looked at the OpenJ9 source code and looked at the overridden functions and the functions that are overridden in OpenJ9, and that's what we consider the API functions. Like we did that for code generator right now. We didn't do it for all the classes, but yeah.
So, I mean, one thing admittedly, we did not do a great job with when with architecting some of the stuff with the current design is we didn't really sort of go through and identify these are what we think should be the extension points of the classes, and these are things that we think should not be extension points. Basically, the way that things ended up right now is that everything is an extension point. Mm-hmm. So I think that I think it would be interesting to actually go through and identify what for each class what we think the actual extension points are, and make sure that they are marked. Like in the evaluation of this proposal, we'd want to make sure that they are also marked virtual as well, so that gets rolled into the overall scheme of things, right?
So I have a question. So for the ones we identified, these are for sure extension points. It's what you're saying is there could be others that are missing just because they haven't been overridden yet, right?
That's right. There's just not there's potentially not a project that's currently extending them, but it might make sense for some project that we haven't thought of yet or haven't worked with us yet on that might want to extend it. So we're going to have that problem as well, even if you're going to use an annotation, right? Because you're going to have to, because in the future somebody might want to come along and say, oh, actually I want that thing to be extended, so I need to make a pull request to add that extension on there.
But I feel like that's beyond the scope of this issue, right? Is to investigate changing static polymorphism to dynamic polymorphism, and then investigating the impact on performance.
Right, that's current performance, the way things are right now.
Right.
If this is now going to be the way that things will be done, like this is now the new extension mechanism that's being proposed, we want to make sure that if you're adding virtual to a lot of functions, we want to make sure that virtual is added to as many functions as we think are extension points in classes, not how many are currently being extended.
Yeah. So,
do you know what I mean?
Yeah, I know what you mean, but I just wonder if that can be a follow-on item to the current work.
I would disagree with that, because if you have, say the class currently has 5 points that are extended, but it actually has 15 points that OMR, from a design perspective, has to allow extension, then the 10 things that are not currently extended would not be marked virtual and would not have the OMR API annotation. If you mark those extra 10 things as virtual, you may significantly increase the number of virtual dispatches seen in the C++ code. Mm-hmm. That could have a significant impact on compile time as a result of the quality of the code generated by the C++ compiler. So you need an upper bound set on the number of methods that need the virtual keyword to gauge the maximum impact of switching to a virtual inheritance model from the current static polymorphism. Because if you go with only the things that are currently extended and don't include the superset, you could be grossly underestimating the number of virtual dispatches that you may actually encounter when the extension points are fully sort of fleshed out from the current design. And I would be concerned that a pragmatic experiment may underestimate the true cost in the long run, and we could make the wrong decision as a result.
I think the point Andrew just brought up is very good. In my mind, just this discussion kind of supports Shelley's point that it's probably beyond the scope of this immediate change to start looking at what extension points are not currently being extended. My thinking would be that for this change, we just look at virtualizing the current extension points and adding that OMR API annotation. And once we have that, it becomes just really an API change from the perspective of OMR to make the other functions virtual that we think might be extension points. And then we can have a discussion at that point regarding the design, performance implications, et cetera.
Well, I guess the thing is, though, Leo, that if we went from static to dynamic, there's a cost there. And my concern is that if we do the evaluation in a confined sort of subset of the extension points, you may miss a cost that you're actually going to have to incur if you're going to include a language that's radically different from Java and your experience with it.
I agree with that, but what I'm trying to say is if we do this evaluation now and the performance is terrible, we end right here, and we don't need to.
Yeah, I think that it's. I think that it's. I mean, it's a maybe a good experiment to go ahead and try it with just a set, but with the thinking in mind that this may not become the actual solution.
Right.
Like I mean, performance neutral is probably a good starting point.
Right. If this experiment goes well, then we can look into the second step, which is identifying. Well, that's a much bigger endeavor too. It's basically saying now we need to identify the API set for OMR compiler components.
Right. I mean, I think that the bar needs to be like in terms of accepting a change, like a sort of a fundamental change like this. I think the bar needs to be a little bit higher, like kind of like what the point that Andrew was getting at there was like we need to understand what the extension points truly are, and that does require input probably from all of us to identify where they are, and then make that change, and then reevaluate performance. But just an assessment of the performance of just the extension points that we have right now, I think that can certainly go ahead. And in fact, that data would be useful anyway, because
that's a necessary step, right? Like I feel like this is a necessary step. The other step is identifying what the APIs are. Right. Then we can, along with this, and adding the set of APIs that we identify as a team. Then we can add the API, add virtual to all the API calls at that point, and then do another evaluation of all the benchmarks and whatever in the bag of performance testing that we're required to do to evaluate what the performance is at that point, and say, okay, now, because I feel like this is a necessary step in the evaluation saga, I guess, to say we're switching the programming paradigm from static to dynamic polymorphism, right? And the other step is API. Like this is beyond the scope of this issue to identify what the API is for the compiler. But we don't know what the API is today.
So if you're talking about the API for the various classes, is that what you're talking about, or are you talking about the external API to the compiler?
Well, the view I have today is the compiler is extensible, whatever way, like everything is extensible, right? You can add.
So I think that the two questions kind of need to be answered, have to be answered together. Like I don't think we can commit saying, yes, we're going to go and we're going to switch away from the static polymorphism that we have without knowing the impacts to all the true extension points of that API of each class, because it could be quite costly. And if we make that switch.
So the other question I have is, like, today we have dynamic polymorphism with virtual calls in the code base already, and we have static polymorphism with self, invoking with self calls. Even with this issue, like, if we went ahead and did all the modifications, did the virtual, did all the performance evaluation assessment, and let's say it was performance neutral or within some threshold, we're happy with that. Can we not commit that and just for that set and then leave the rest? Or do we have to, as the goal of this issue, implement everything? Like, today there's this hybrid solution where we have virtuals, we have static.
So I think that the thing is we need to have some concept of what we believe the upper bound is. Now, one way to get the upper bound is to identify them all, mark them all virtual, and do all the performance. The other way, if that is not tractable in the scope of the item, is that we do what we have at the moment, but we will need to have some way of trying to extrapolate what we believe the extra overhead may be. Because the last thing I would want to do is to commit the project to a plan of using virtual because it has all the wonderful things that it has and the software engineering benefits of it, but then end up fighting one or more of the compilers on one or more of the platforms that OMR needs to build on, tooth and nail to try and get the performance that we need, when experience long in the past was that there were some compilers that could struggle with very large vtables and devirtualization and that kind of thing. So while we may not have to get to the point where every extension point is identified, we may need to try to come up with some means of at least estimating what we think that's going to be. I don't know how we do that, but I strongly believe that we need to have some idea of the upper bound.
I agree with that. But I think simultaneously, maybe at the same time as this item progresses, we can start an issue on identifying what the API, the API message should be within the compiler component for each class.
For each class.
Yeah.
So one of the things I was going to suggest is that it's tons of effort if you guys go through every class and try to figure out what the API is. But if we use this heuristic, okay, has it been overridden somewhere, then we at least reduce it from having to go through 100 to 100 functions, we're now down to 50 that we know for sure are API extension points. And then you need to only look at the remaining 50 for a class. So can this be done more on, once we submit a pull request for a class, you look at the remaining functions and see if any of those need to be, if any of those are recognized or not? Kind of make use of this as a way to reduce the number of functions you need to look at?
I think the point is even the ones that have been overwritten, there can be remaining functions that are not overwritten, but could be by some other projects in the future. So
yes, so what I'm saying is that, so assume a class has 100 and only 50 of them have been overridden. It doesn't rule out the other 50 because they could still be potential extension points.
Right.
But now you don't have to go through 100 of them. You have to go only through 50. So like when Timer, let's say, submits the pull request, he's only submitted suggestions for 50 of them. So once there's a class that we're trying to virtualize, you could go through the others and see if those other functions are extension points or not. I'm just trying to say that using this quote-unquote heuristic of seeing what's been overridden reduces the number of functions you need to look at as potential APIs or not. It already gives you a set of, this is for sure part of the API, let's look at the remaining part. Because I don't see how you could go through, I don't know if you want to, but if we want to get that upper bound, it means collectively you all have to kind of go through all classes, all functions, and decide which of those are API points.
Right. I think that's something that we have to. I mean, in fact, we should have done that when we first did this kind of transformation a couple of years back. But I think that if we're talking about making another change to it, that the time is probably right that we do this now. So, I mean, any kind of way of sort of focusing the efforts on the different classes, like if we get a subset of functions maybe that we need to consider, that would certainly help. I do think that I think looking at if we can get more than one, like doing the performance analysis, the performance investigation on an aggregate of these classes together might be more effective than looking at doing the analysis on individual classes. Now how many classes right now are extensible? 37, 40, something like that? Are there more than that?
Samer should have that. Samer, do you have that data?
So,
not at the moment, but
yeah. So I'm going to say it's about 50 classes. Let's say if it's 50 classes, is it possible to do that performance investigation with that 50 classes, and as opposed to just sort of one at a time?
Yeah.
And if you are going to limit it, I would say Node is probably a good one to start with because itself is used quite a bit in there, and probably the code generator as well.
Well, ideally, I would like to do in chunks, if not all together.
We try to do as many together as you can.
Right. Yeah. Minimum.
There's some particularly thorny one, maybe leave those out, but for the most part, try to capture everything. Because if you're going to do that kind of across the board perf evaluation, different platforms, different compilers, we can't be doing n runs of n iterations of that. Right? Or we could, but it would be expensive. Yeah.
So, I guess like if we do them in chunks or whatever, let's say there's in 2 or 3 batches of changes, and then after that point, we still have to look at the API that we.
Well, it's what you said, right? If you did the evaluation with as big a set out of that 50 as you can manage,
let's say we did,
and there's already a big problem or the signs of a big problem, you extrapolate that very hand-wavily based on what you think you will add if you went and really added virtualization points to the API, and extrapolate that to a number, and you don't feel comfortable with that number, you're not going ahead with that.
What about the other side? Let's say it did come back with neutral results. What do we do?
I don't think we're saying necessarily able to say anything at that point. I think we need another discussion, frankly, with those results in front of us and just how that code looks. Like that would be a good enough point, I think, to assess the benefits from an engineering software engineering perspective, as well as even if it's not a catastrophic slowdown, right? If it's 3%, well, if you're going to add 5x more extension points, that's 15%. Okay, put the 15% number on one side and look at how the code looks on the other side and have a discussion. I mean, there's no objective thing here, right? It'll come down to a fairly subjective discussion, I think.
So there are a couple points too, I guess, in the proposal. If you look at the issue, there's one where we say if the functions are intended to be used only in OMR, we keep static polymorphism. The other thing is we declare this macro, whatever it's called, OMR API or extension, and it's possible for the downstream projects to override that that macro to declare a final or whatever, so that it's for faster method dispatch. So those, like, how does everyone feel about keeping static polymorphism in functions that are only used within OMR? And then the fact of using this macro to possibly declare things as virtual final. Virtual final for methods that will, for OpenJ9, will not be extended after, and it'll be resolved faster by the compiler.
My initial reaction is, if you're going one way, go the whole way.
Okay, so that's the first one, right? Even if it's just used within OMR, we will still do the virtualization.
It's my opinion. Having two approaches in the same code base is a recipe for confusion, regardless of the ratios of those two.
I mean, it's bad enough at the moment that you need to remember selfs, but if I need to remember self in a subset of methods,
exactly,
all hell is going to break loose. That is going to be an absolute nightmare.
Okay.
And you're going to have methods being dispatched to the wrong place without even knowing about it.
Because you don't have a checker in that point. Well, you need to modify the checker to.
You need to modify my brain.
So, Samer, I think that's the first point bullet in your proposition section. I would delete that and change that to virtualize all the calls that are overridden. And then what about the other point of?
Just to follow up on that, so that means that the heuristic that Samer is using right now would change, because he was only looking at overrides in OpenJ9. So now it's basically all overrides, whether it's within the OMR namespace or OpenJ9, right?
Yes.
Okay.
Yep.
And then the other point was, so initially we proposed this macro to, well, number one, that we can maybe later on use a tool to aggregate all the API calls and generate some nice documentation for OMR and say these are all the this is the API for OMR compiler. So the macro can be used for that purpose, but the other use is that, for, like, say OpenJ9 wants to declare virtual final methods, so because it knows no one will override them anymore. so the compiler can do a quicker job doing the call dispatch. So we can also use that for that purpose. I think there was some discussion about using the same for OMR extension versus this other macro. And if we do things in stages, that cannot happen. If we do everything in one go, then they can be the same macro. I don't know if I'm explaining myself. So currently we have this OMR extension macro, and that identifies the OMR extensible classes. And for all those classes, there's an OMR checker that will check all the invocations of its member functions and making sure that the invocations are accompanied by the self thing. And this new thing is called this other. Let me just call this OMR API that we proposed that for all the virtual calls. So initially in OMR we can just declare OMR API as a virtual for OMR. And then we can also use it as an annotation later on for Clang plugin or whatever to generate some API sets for OMR compiler. And then later on, if another project, say OpenGen or whatever other project, can overwrite that macro and say, now change that to virtual final.
I don't see how that's going to work because OMR API is going to be all over a bunch of stuff, and not all of them are going to be final at any given point in time. So, I mean, I don't see how that, like, if it's virtual, put the virtual keyword there.
You're going to have to change that macro on a particular function. That's what you'd want to do, right? Like, I know that particular function, I know I don't want it to be extended right like that.
Oh.
Because if you change the macro, you change it for everybody.
Right.
And that's what you want.
And that would break a bunch of stuff if we're
Probably
internal.
I see. So,
because if you have something in the common code gen that's overridden by the X code gen or the Z code gen or whatever, right? Because we're talking about going fully virtual. Then if you go fully virtual, your macro becomes pretty meaningless. You can't, from the point of view of using it to change the code. Marking the points, it certainly has a utility, but.
So if that's the case, then my other question is, if we just use virtual to mark all the API calls, does there exist methods that are virtual currently that don't belong to the API set or shouldn't belong to the API set?
Are there methods that are currently marked virtual that should not be marked virtual?
Right.
Absolutely.
No, should not be marked, should not be included in the OMR compiler API.
I think the answer is that. I mean, there's a lot of methods marked virtual. If you're asking, I mean, we went through that list of methods and assessed each one for appropriateness belonging to the OMR API. I can't sit here and say all the methods would make the cut. We would probably take away some of those.
Then we still need a macro to say this is an API method.
So I think having the macro does make it clearer, but maybe it should just be an annotation, defined as an annotation.
In addition to virtual. So you're saying
You're saying that you'll have n virtual functions, but not all will be appropriate for the OMR API. So you need some other way of.
Right.
So what's the value of adding? So is it only the extra tooling that you get that you can build around this that gives the value for adding this OMR API annotation as opposed to
because otherwise why do we need it? Right.
Well, virtual is telling it that you can't extend it at that point.
But that's assuming all the virtual methods are in the API today.
But why wouldn't they be?
I don't even know what the criteria are for putting something into the OMR API. How can I sit here and say, yes, all virtual methods adhere to the standard that is required to be part of the OMR API? Right.
I think that's a good question. What exactly is the OMR API? Is it just things that you can override? Or?
The OMR API.
Yeah.
So maybe that's a question to go back and clarify or flash out.
About OMR API?
Yeah.
don't think you're going to get an answer anytime soon.
We can start talking about it now, or schedule a series of meetings.
Schedule a series.
Yeah, well, I mean, we can talk about a few classes at a time and identify these APIs.
From my perspective, if we're going to have something called OMR API, and it's going to get sprinkled over methods in some way, how you come up with the criteria, well, I'm not sure about that, but I need a crisp 1 to 2 sentence description that allows me to make a decision as a reviewer as to whether that is correct, and to be able to convey to people contributing to the project as to when they need to apply it and when they need to not apply it.
Right.
And I'm not sure that I understand what that crisp 1 to 2 sentences is right now. And if somebody can come up with that 1 to 2 sentences, then I might be able to make
and
a better
ultimately, it's going to have an impact on the OMR releases that we do as well.
Yes.
Because if you're now adding a new API method, then you are.
So the other side is to say, when we decide on the OMR API, what it is, we also look at all the virtual functions we have today and say, do they have to be there? Like, are they? Right, like today we're not confident to say all the virtual functions should be virtual, and hence they will be part of this API because we don't have some other annotation to say what the API is.
Right, but if you introduce an annotation without a set of rules about it, then the annotation becomes as meaningless as the virtual keyword, and we just have another thing floating around in the code base that confuses the hell out of everybody. So I think that we need to have some kind of disciplined way that this is supposed to be used, and a mental model of how it's supposed to work, so that people doing reviews can be consistent in criticizing the presence or absence of the annotation, right? I would hate for one reviewer to go, put OMR API on there, and then somebody else comes around with their pitchfork and says, hell no, get it off there. That's not a good experience for anybody, and it just confuses the project. So that's kind of where I see that there might be a danger in it.
So it sounds to me that we need to...
I mean, I think that the more general problem that you were just mentioning about how we need to review, I guess, systematically review a lot of these classes, look at the API of all of them, try to understand, should this be an extension point? Should this not be an extension point? If it's marked virtual, should it be marked virtual? And then kind of go from there. I mean, I think it's just part of the whole exercise that we need to happen.
So it sounds to me that we don't want another macro. What we want is to inspect what we have today, things that are not marked virtual but should have been marked virtual, things that are already virtual but maybe shouldn't have been marked virtual, and figure out what the correct step is on the per class or whatever. I mean, we can do a few of these classes at a time to drive towards a complete set of API that's for OMR, the compiler anyway. And then when we do releases, then we can say, this release, we changed this.
I would pick the hardest classes to start with. Like pick the nodes and the code generators.
Yeah.
Is there anything else more?
Instruction
already uses the hardest. Are those even the hardest classes, or
in terms of self? In terms of proliferation. Proliferation, yes. Node is pretty big. Cogen, maybe. I just had it in my head. In there I had. Sorry. But yeah.
The reason I asked.
Symbol,
that's the one.
The reason I asked was that there may be a deeper question or a more difficult question around extension points of optimization.
Yeah. Because there's virtual inheritance in there, but the virtual inheritance is not meant as extension point. It's a means of recycling code between related implementations of optimizations that, rightly from a software engineering point of view, should share code, but if you go and start replacing those methods, good luck to you. It probably ain't going to work.
How do you accommodate that then?
Well, most of the ops are not intended to be extended. If you need radically different behavior from quite a number of the ops, you need a different opt. The only ones that have a notion of extension really are like things like simplifier and things where you have a table of handlers for particular opcodes. And if the opcodes are extensible, then you need some special handling for those, or where the meaning of an opcode is possibly refined by a project, a write barrier being an example where a write barrier is a side effecting write. The side effect may be reporting to the GC, it may be doing something else. The particular side effect attached by a particular implementation to that may vary, and how you want the simplifier to work with your write barrier may be different. But that's a very constrained, like it's already a table, it's a function table, right?
Take a different example from a different op, let's say, right? Version or loop version, or let's say you have a method called version natural loop. Okay. So that version natural loop today knows about certain checks that are there in Java. It knows how to version with respect to them. It understands the semantics of those opcodes in the context of Java. To say, well, just make version natural loop virtual and you just get to define everything. But practically everything we have in versioner is callable out of version natural loop. So that would essentially delegate the whole task of loop versioning to front for a new product, which you don't want. You do want to help them with that task. But that may mean extracting out parts of what is currently in version natural loop, creating virtual functions for those, and putting the rest, some of the infrastructural stuff in non-virtual.
Yeah.
That's the sort of complication I'm talking about, right? That will hit you across the board in many places. Let's just call it that. Maybe it won't hit you in some very simple places like value propagation. Well, you get to even put value propagation in a bucket. Simplifier is the only place where you have some chance of an uncomplicated route through this. Everywhere else, it could be complicated.
I have a couple of thoughts, I guess. One is like, this is just discussing now, one is to change the code to identify certain queries that can be different for this project versus that project, and then do this action or that action, and they can override those things per project. The other thing I was thinking is then even this upper bound, let's say today we're not ready to well, I guess these functions are already virtual.
So the optimizations are all use virtual inheritance from the optimization.
No, but let's say this natural loop version natural loop, for instance.
I don't think it is virtual.
But you also don't believe it should be in the future? Or I guess what I'm trying to say is the upper bound that we were proposing earlier, if today we don't, if we decide, okay, this should not be part of the API, we don't do virtual, a year from now, we change our mind.
Well, the optimizer does not use static polymorphism.
Optimization, you mean?
Optimizations do not and never have used static polymorphism.
Right.
So discussion here was about switching from static to dynamic polymorphism, or at least that was my understanding, which is what Sarah and et al., I'll say, are working on. And if the discussion is around that, then the area of the code we have to be concerned with is the set of stuff that's currently using static polymorphism.
Right. So then the discussion went to a separate place, which was around this notion of an OMR API versus what is currently virtual.
Yep. I don't know. Yeah, I mean, different parts of the code base are at different points, I think, on that journey, right? The optimizer is in a different place than the code generator, than the IL.
And I'm just saying, there was just retracing our path from 10 minutes ago was, yes, there are some classes that are foundational classes where there's a lot of static polymorphism used, where you can analyze and come to a conclusion about that category of problems or that category of classes. There's a different category, I'm saying, which are not core foundation stuff, but which are more complex, in terms of extracting out an API from them and in terms of what's currently virtual and so on, that question.
Yeah.
That other category does not use static polymorphism much.
Yeah.
But it's still a different category.
Yeah.
You do
but I think that point is, even though they might be virtual, they're not part of the API. Or we don't recommend them to override these functions, right?
I don't know if we know the answer to that yet.
Yeah, I can't answer that question. Or
I think we'll have to take that on a case-by-case basis.
Case-by-case basis, right.
So what are the action items now? Like, he can, Samer, for instance, can go ahead and change something, like code generator, you said, symbol, node, do a batch of these.
Change for the purpose of evaluation.
Right.
Yeah. So if the next step is to do evaluation on a variety of different compilers,
yeah.
I think you should choose the classes that'll probably have the most impact in terms of changing from self to not self, to virtual, I should say, and then evaluating those. So just off the top of my head, I picked those three classes.
Right. So he can go ahead and do a set of these classes. We'll evaluate the performance if it's within some tolerance.
Samer, do you have data on which classes or which classes have the most number of self calls?
We still don't have the number of self calls exactly, but we have how many what are the classes that have most number of overrides.
Okay, but from from the
which
code.
ones have the most overrides then?
No. Oh, that's your question. Sorry. Go ahead.
This is asking you which ones did you find have the most number of overrides?
I still didn't look at it because we were planning to virtualize the code generator.
Oh, okay. That's fine.
So you have data, but you didn't aggregate it yet.
Yeah. I can just look it up in an hour or something.
Okay. I'm afraid I have an existing commitment, so I have to duck it.
So the action point, based on what I understood, is that I would virtualize all the functions and the important classes, which are code generator, node, code gen, symbol, and structure.
So I just picked those off the top of my head, but that's sort of why I also asked if you knew how many, for all the classes, for the extensible classes, which ones called self the most. And I think those are the ones that will be, in terms of if you wanted to put a prioritized list of all these 50 classes together, the ones that had the most self calls in their functions would be the ones you want to start with.
Yeah.
And even doing like the top 10 of those might be worth it, right?
Mm-hmm.
You'd get the compilation, you'd probably get.
Would it make sense to think about the classes that have most number of overrides, or the class hierarchies that have most number of overrides? Or it might not be.
Either way, it would still be a virtual function either way, right?
Mm-hmm.
Mm-hmm.
No, he's asking you the criteria to pick which class to go after.
Yeah.
Not sufficient to pick the most number of overrides in the class. Is that something I think he has available in his database?
Right now, yeah. Because I'm thinking that the classes that have most number of overrides are probably gonna have most number of self calls.
But I'm not sure because right now the advice has been to use self. Actually, the requirement has been to use self on every method.
If you did its code within the class.
Yeah. Well, okay. You can do that analysis. I would, but regardless of what the results are, I think you need to include node, code gen, symbol reference, regardless of what the answer is.
Yeah.
Okay. And I have a question about trying out the different compilers. So, Shelley, the benchmarking infrastructure or whatever you have that you would run this on when we give it to you, do you already right now try different compilers, or is this something we have to then change to try out?
I think that's so we have a set, like we have a build environment that will build on different platforms. That's how we build for our product. That's how we'll build OpenJ9, and then we'll run those with the benchmark that are required, I guess, that to satisfy some performance degradation threshold. But if that goes well, then it stops there. If it doesn't go well, then we will look at like using some of the more modern compilers on those platforms and see if there's improvements and try to argue for the case of changing it to dynamic polymorphism. But I think the first step, I think the first step is to make the changes for those classes. I personally think the classes with the most overrides will probably be a good, at least the first cut, to take all the top 10 or 15, whatever number of classes that you choose to change, and then we'll do this evaluation once, see how it goes. Because I think the problem is the self is only used within the class hierarchy itself. When you create the object and call it that way, you're still indirectly calling self, but it's not syntactically in there.
So if the current compiler, like using the current compiler, we don't get much performance degradation or within the acceptable threshold, then we don't need to try other compilers. That's what you're saying. It's the other compilers.
That's my understanding.
If the current compiler shows
like neutral performance impact, then we don't need to.
You mean like newer compilers?
Yeah, then we don't need to look at the more newer compilers, right? Like this stuff.
Yeah. But to Andrew's point, I think we have to try this across a variety of architectures and operating systems, which is what the performance runs could do.
Right. The platforms and stuff, like the current with the current compilers, we'll take care of once we get the changes from them.
Okay. So, I have two questions. So my first, two and a half. My first question is, are we using self from inside of constructors?
We are, but that's not correct.
Okay, good. Okay, because
we actually have
we try to avoid that. Yeah,
we have
an issue about this.
Already.
Yeah.
Okay, because you can't use virtual functions from inside of constructors. So if that was something that we were looking at doing, you'd have to change the way that you're doing
undefined behavior. Yeah.
And then my other question, which you guys could probably also answer quickly, is how are we actually selecting the concrete implementation of like an extensible point? Because when we switch to virtual, doesn't that mean that we would have to, or probably should, change our startup APIs so that an application could inject the implementation of something into the compiler at runtime?
Yeah.
So like they would bring up their own concrete implementation and then pass it in as a pointer.
It's a TR mapping, right?
So wouldn't we be changing our startup APIs to accommodate dependency injection? And would that be a good way to control and sort of like express exactly what our extension points are to applications? Or
I didn't get that.
So, like maybe the JIT compiler startup API takes a pointer to some kind of like node factory or symbol factory or something like that. And the symbol factory would have a virtual call that constructs some kind of concrete implementation of node that's language specific.
Mm-hmm.
And that is how an application would provide like concrete behavior to the compiler by constructing the dependency and then passing it into like the JIT builder thing, the JIT factory.
I think we do that through the mapping from TR, from say if you want the OMR version or the J9 or Ruby to TR.
But does that happen statically at build time though?
Yes.
Okay. So would there ever be any interest in getting rid of that so that an application wouldn't have to make a code change to, or work with the build system and develop a custom distribution of OMR? They could just work with OMR as a library.
With in the world of let's say JIT as a service, where we do compilation of different in a polyglot sense.
Yeah.
Where
Yeah, that would be a good
combine. So yes, there is a. We have to think about. So we actually used to be able to do cross compilation.
Yep.
Of not in the. We do the polyglot sense? No, we used to do it in. No, we probably could do it in polyglot sense because we actually virtualized the front end and the code generators. So, but we stripped, when we open sourced this, we stripped all that out. So we basically, the simplifying assumption that we made in order to get this up the door was you're going to cook up a new compiler for whatever language front end architecture pairing that you care about. But if we're going to come back a bit from that, which I'm not opposed to at all. No,
okay.
I mean, I'm not. I'm open to anything. Then that might, what you're just saying, might be the way of doing it.
Okay. Yeah. I think like virtualization kind of opens a lot of doors for the
yes.
for us beyond just like simplifying the code base. Yeah. Okay. Cool.
You had a half question left?
My half question was basically, do we ever see a point where somebody could use the OMR compiler like a classic library and use dependency injection to just sort of tune the behavior? And the answer was maybe yeah.
Service rule, yeah.
Yeah. Cool.
Okay.
Okay.
Any other? Go ahead.
I was just going to say, so I guess the summary of the action points is that we try those classes that were already mentioned. We'll pass them, once we finish those changes, pass them on to Shelley. We'll run them on the benchmarking infrastructure that you have available, and then we basically report back those numbers and see what we think about them before doing anything else, right?
Yeah, I have one more request, I guess. Once you decide on the set of, can you let us know, and so we can start maybe looking at those classes and decide on what the APIs should be for those classes in parallel to your work?
So when you say deciding on the set of classes, you mean to look at the number of overridden functions and look at the top 10?
Yeah, so sure. Yeah, let's say you looked at the set of, I don't know how many classes, 500 classes, and altogether 500 plus or something, and out of those, however many have overridden functions, you pick the top 10, let's say. Once you have the top 10, can you let us know? I guess we can get on the agenda to talk about what the APIs.
There's only about 50 extensible classes.
Okay, so let's say, so out of 50 extensible classes, we pick 10, and then we can get on the agenda on the APIs for those 10. So they don't have to be all in, like we can do that in parallel, right?
Okay, yeah.
Okay, any other immediate thoughts on this issue? Okay. I guess we'll adjourn. Thanks very much, Samer, for talking through that.
Thank you for the opinions.
Great. Thanks, everyone.
Thanks.
Bye.
Okay, bye.